Hello everyone, good morning. Welcome to the rise and fall of AMSI. A bit about me. My name is Tal Lieberman. I'm a researcher focused on reverse engineering, and I mostly do low-level stuff. For the past 2 years I was the head of the research team at Silo, and there I worked on process doppelganging and atom bombing, which are attack techniques on Windows. And currently I'm one of the founders at Polarium, which is a security company that provides software research services to big companies, governments, and startups all over the world. And today we're going to be talking about AMSI. We're going to start off by talking about an introduction. We're going to talk about script-based threats and fileless threats. We're going to talk about obfuscation and the cat and mouse game that attackers and defenders play in the scripting domain. We're going to take a look at AMSI from the developer side, from the app developer side, and from the security vendor's perspective. Then we're going to take a look at building and providing your own AMSI provider. And once we know all this, we're going to take a look at bypassing AMSI, because this is blackhat. And we're going to really try to think if AMSI is the tool that we need to deal with obfuscation, and if this is a long-term solution or not. So, script-based threats. Well, I feel like for the past 5 or 6 years, every single article that mentions script-based malware tries to make it seem like there's a trend of script-based malware. Well, I think it's not really a trend anymore. I think it's pretty mainstream. So I think it's safe to say that more threats today contain some kind of script-based component in them. And the reasons for this are that, first of all, PowerShell is available, or BBScript, or on Linux you have Bash, is available in all platforms, on all machines. It's vastly used in domain environments, right? You have system administrators who love setting up your environment by using PowerShell scripts. And scripts are faster to develop, and there's a minimal skill set needed to achieve a decently functioning malware. Now, another reason that they choose to use scripts is that scripts are text, and text is easier to obfuscate than machine code. And empirically, antiviruses and security products have had trouble monitoring scripts compared to natively compiled code. And this is probably because when you have an engine such as PowerShell or the .NET framework, or Java for that matter, when you have an engine that's running code interpreted, it's very hard to tell where the engine ends and where the code begins. And this makes it more difficult than when you try to inspect machine code that's running, that's compiled natively, and then it's very clear where the image ends and where the operating system begins. So fileless is another buzzword that's been thrown around a lot. Basically, a file always has to run if we're gonna survive a reboot, except for very special cases, like if you find a vulnerability in NTFS driver and you're able to get the kernel to run code while it's parsing the raw NTFS data, well, okay, that will qualify as truly fileless. But in all other scenarios, we're talking about abusing a signed executable, such as PowerShell for that matter, and having it run your code. And then your code is probably stored somewhere in the registry or in a file, but there is no file to scan for the antivirus for that matter. Now, a very simple example you can see is here, command line of PowerShell running a download string function to download something code from pastebin and then executing it at runtime. So the malware comes from the internet, but PowerShell is the one downloading it and running it without putting it on disk. And there's not much for a security product to scan at this point, right? Now, obfuscation, according to Wikipedia, in software development, obfuscation is the deliberate act of creating source or machine code that is difficult for humans to understand. Well, I do agree with that, but when you're talking about malware, scripting, and obfuscation, you're not just trying to avoid comprehension by humans. You're trying to avoid the inspection of security products that are trying to understand what it is that you're trying to run. Now, there's a cat and mouse game, a very simple one that goes on between attackers and defenders in the scripting world. Now, we'll start with a simple example. Let's say I have a function that runs write host malware, which is basically like a hello world for PowerShell that prints out malware. So a simple signature would be, okay, well, if I see write host, single quote, malware, single quote, then that is a malware. So a simple bypass would be to change the single quote to a double quote, right? And then the antivirus would say, okay, well, I'm going to ignore the single quote. For me, as far as I'm concerned, it could be a single quote, a double quote, or any other character. And so this is a simple bypass. And this can be a simple signature for that. And this can be bypassed by using string concatenation. And this game can continue on and on. We can use base64 encoding. And then the antivirus can decide if it wants to either emulate the base64 decoding or to create a signature for the actual base64 data. Both things are quite easy to bypass. And then malware authors begin to use things like XOR-based encoding. So antiviruses implement an emulation for that. Until finally, malware authors realized you could just really run an encryption algorithm, because PowerShell allows you access to all types of encryption libraries that are available to .NET. So you could just simply use AES encryption for that matter, and you're able to execute whatever you want. And for the antivirus, this would be very, very hard to brute force, probably impossible. And we can, as antivirus products, we can try to identify the key in the algorithm. But what if the key comes from like a file or a registry or the internet? It becomes very hard to do reliably. So the point is a bit of creative thinking, and we can slip past the most advanced detection algorithms. Now, at this point, antivirus solutions begin to write signatures for the obfuscators themselves instead of the actual malware. And according to Lee Holmes from Microsoft, he says that in fact, that is what it accounts for the vast majority of signatures for script-based malware. Now, if we have an obfuscation that is as trivial as the one we saw before, which is here again, then trying to create a signature for something like this would generate an unacceptable number of false positives. At this point, we have anti-malware scan interface, AMSI, or AMSI, which enters the picture. Now, there's a long text on MSDN that describes the purpose of this. I'm going to save you the trouble of reading it, and I'll explain. So, AMSI, or Anti-Malware Scan Interface, was introduced to help AV vendors deal with script-based threats. It's a mechanism that standardizes the scanning of content, right? So any app can request any content to be scanned. It can be a file, it can be text, it can be a buffer. And any security vendor can implement an AMSI provider and register to receive those scans. So basically, we have the OS becoming like a middleman between application developers and antivirus developers, where any app can request content to be scanned, and any antivirus can scan that content and return an answer to the app. Now, the supported vendors for AMSI are Windows Defender ATP, which is the paid version of it, which is Microsoft, so that's not a big surprise. But also ESET supports it, AVG, and Bitdefender. And the funny thing is that if you Google Bitdefender and AMSI, the first thing you see is, how do I disable AMSI service provider? So that was kind of a funny joke, but it's really the case. So let's take a look at AMSI from a developer's perspective, right? Let's get into the mindset of someone who is writing an app, such as the creators of PowerShell, and they want to use AMSI as clients. They want to send requests to be scanned. So we start off by looking at the documentation on MSDN, right? And we see that the documentation is split into enumerations, functions, and interfaces. Now, out of the enumerations, we only worry about a single enumeration, which is the AMSI result. Now, this is just a list of different values that a scanner can return for a specific content scan. Now, the different values that we're going to be discussing are the result clean, which means I've scanned it and it's clean. It's not a malware. Result not detected, which is the neutral value. It's I've scanned it. I don't know that it's a malware. I don't know that it's not a malware, so I haven't detected anything. And then results detected, which is I've detected a malware, right? Then we have the functions. Now, we have a bunch of different functions here. Most of them deal with initialization and uninitialization. But the interesting two functions that we're looking at are scan buffer and scan string, which are two functions that an app developer can use to request content to be scanned. Now, if we take a look at scan buffer, we see that it accepts two parameters that describe the buffer and an output result. So we have the buffer pointer, which points to a buffer to be scanned. We have the length parameter, which is the length of the buffer. And then we have the result. So that's that. Now, the result will be the AMSI result, as we discussed earlier, one of the values that you can choose, detected, not detected, and clean. And according to the documentation, an app should use AMSI result is malware to decide if the result that it received is a malware or not. Another function is the AMSI scan string, which is exactly the same function, except in this case we receive a string instead of a buffer and a length, which means it's assuming a null terminated string. And it seems like a sort of a wrapper around AMSI scan buffer. And if we take a look at it in code, we can actually see that we have a bit of error checking here and here. But mainly what this does is simply calculate the length of the input string and then calls AMSI scan buffer with the buffer and the length that was calculated. So for our purposes, AMSI scan string is the same as AMSI scan buffer. And as for AMSI result is malware, which we're supposed to use to check if we're supposed to block content, well, this is just a macro from AMSI.h. So just check if it's larger than AMSI result detected. So now that we know how a developer would go about using AMSI, we need to take a look at how PowerShell uses AMSI. So let's take a look at PowerShell. Right? PowerShell is where theoretically AMSI is most effective because most of our threats are either in PowerShell or VBScript. But PowerShell is open source, so we can take a look at the code online and just figure out how it was implemented. And there it's going to be very easy to inspect how AMSI was integrated. So I'm going to open up PowerShell on GitHub. And as you can see, we're looking at security support.c#. And at the bottom we have a simple class called AMSI native methods, which will export all the different methods that AMSI DLL exports. So we have AMSI initialize, uninitialize, scan buffer, scan string, etc. This is a very simple, thin wrapper around the AMSI API from AMSI DLL. If we look above, we have a more thick, more high-level wrapper that's called AMSI utils, which has an init function. Now this init function is going to call AMSI initialize, and if the initialization process fails, we're going to put AMSI init failed equals true. This is very important because we're going to come back to it later. Now, at this point we can take a look at the function scan content, which on Unix just returns the neutral result, not detected. But on Windows, it calls WinScan content, and if we take a look at WinScan content, we see two things happening. The first is we're checking if the initialization failed, and if it failed, we will return result not detected. So if a scan occurs and it failed, then we're going to say, okay, well, I can't scan, so I haven't detected anything. This is the neutral result. Now the problem here is that we're assuming, the PowerShell code is assuming that whatever the provider answered, whether it's a valid return code that says I've scanned it and it's not malicious, or I had trouble scanning it, or I couldn't even initialize AMSI because of some attacker method that we're going to see later. At this point, PowerShell is going to keep going as if AMSI didn't exist. So AMSI is like a best effort thing, but if there's a problem, it's not going to be propagated to the user. Okay. And then the last thing that happens in scan content is we call the scan string method, and whatever the result is, we return back to the caller. And so that is the wrappers of AMSI in PowerShell, right? Now we can take a look at the code in PowerShell that really compiles code and that actually calls these AMSI wrappers. So as we can see, whenever we want to run a command in PowerShell, we need to compile the text into something that can be executed. And this function called really compile, which is called by other functions, is the function that is in charge of compiling. And as you can see here, we have the call to create the compiler and the call to the function compile. But right before this, we have perform security checks. If we take a look at this, we can see simply a call to AmsiUtils, as we saw before, scan content, right? And if the result is result detected, which is malware, then we're going to raise a parse exception saying that the script contained malicious content. But if any other result is returned, whether it be not detected or even a value that's larger than result detected, which according to documentation should be considered malicious, PowerShell is going to ignore that. Okay. So now that we know how AMSI works from a developer, we saw how it was integrated into PowerShell in its source code. We can take a look at how AMSI looks from a security provider's perspective. What we have here is we have three main interfaces. We have the AMSI stream, we have the anti-malware, and the anti-malware provider. Now the AMSI stream is a very simple concept. It's a wrapper around an object that needs to be scanned. So whenever we want to scan something, whenever we want to request a scan, our scanner will receive an AMSI stream object on which it can perform the scanning. Now this object has a read function, and theoretically we're supposed to use this read function in order to read the content from the buffer that was requested to be scanned. So when I tried to implement my own provider to kind of learn how this works, I was trying to use the read function and it kept failing again and again. So I took a look with my debugger and I saw that I found the address of the function that I'm calling, the read function, which is of a class AMSI buffer stream. And if we take a look at this function, we can see that not much is going on here. There's a logging that takes place, and then we return error not implemented. So this is a nice little concept. It's a documented function. It doesn't exist. It's not implemented. But there are ways around this. Now as for anti-malware and anti-malware provider, well, reading the description on MSDN, I really couldn't tell the difference. But after looking at a diagram that we're going to take a look at in a minute, I was able to kind of understand what the difference is, and then that became much more clear when I looked at the code itself. So the anti-malware provider interface, that is the one that is actually pretty clear. The anti-malware provider is the object that the anti-malware needs to provide the operating system in order to process scans. Now, it needs to export two functions, a scan function, well that makes sense, it needs to scan things, and a display name function, which I haven't figured out what it's used for, but it's there, and I forced Windows Defender's AMSI provider to call its own display name function, and the name was Windows Defender, big surprise. And then we get to talk about the architecture. After all the pieces are kind of in place, let's take a look at the big picture. So we have PowerShell, right, calling AMSI scan buffer or AMSI scan string, and AMSI scan buffer and scan string, and also the initialization functions, they all work with a class called anti-malware that we saw before. Now this class is an internal class for AMSI, and I honestly don't know why it's on MSDN, but it's implemented entirely in AMSI DLL, and what this class is in charge of doing is it's in charge of managing all the different providers that are loaded, all the different antivirus providers that are loaded, because you can have more than one provider that processes the requests. Now, this anti-malware will be in charge of loading the various providers and then dispatching the scans to them when the scans arrive. And then we finally have the bottom layer, which is the provider itself, and that layer is, for example, could be Windows Defender's provider or it could be my own. And here we also have the diagram of how Windows Defender decided to implement it. So the RPC, the scans to the service, which creates the scan, and then finally returns the result back. So now we know all the different interfaces, the stream, the anti-malware, and the anti-malware provider. Now, we want to move on to build our own provider because, first of all, it's something that we'd like to be able to do if we're security products, and second of all, it's good to be able to do that in order to try to play around with AMSI and to learn how it works and what we can do with it. So we know what we need to implement, the anti-malware provider. The question is, how do we implement it? Well, anti-malware provider is a COM interface, and Microsoft does provide frameworks for implementing COM interfaces. So there's no need to know under the hood how it really works. And if you want to go down this road, you can use AmsiIDL from the Windows SDK to create your solution and to implement your own provider. And just you have to implement the scan and the display name method, and that'll work. But I do encourage you to forget about the frameworks and implement everything yourself. You will learn a lot more, I can promise you that. And later, go back and use the frameworks. So the best resource for this by far is this link right here. And also I'll be releasing my code samples that you guys can check out. And together with both resources, I'm sure you can follow along very well. So registering a provider. Well, we built our COM object and registered our COM object, which is all documented behavior, and we know how to do it. We now need to register it as an AMSI provider. But unfortunately, AMSI provider registration is undocumented. But that's not going to stop us, of course. So let's take a look at AMSI DLL. Now, I've said that AMSI is an anti-malware class, has an anti-malware class that is in charge of loading the providers. So the loading is going to take place in a function called final construct right here. So let's take a look at this function. Now, as we can see here, we can see a call to a function that I've labeled AMSI load providers. Now this function right here will be passed a list of providers, a list of provider GUIDs, and the number of providers. And actually these are all output parameters that once this function loads all of the different providers, it will return back to me all the different providers that I can then work with inside this anti-malware class. Now, if we take a look at this function, the load providers function, we can see the first thing is a reference to this string right here, which is software Microsoft AMSI providers. Now, this is a pretty encouraging hint that we're in the right place. We're looking at the registry key where you would register a provider. And as you can see here, we have another class that is the GUID enumerator, and we're calling it with start enumerator. So what this class is in charge of doing, it's going to enumerate this registry key that we just talked about, and it's going to enumerate all the different GUIDs, which are IDs that represent the different providers that are registered underneath the class root registry key. So if we move on down, we can see that after the initialization takes place, we call the function next GUID, which will bring the next GUID in the list. And once we have this GUID, we're going to call a function that I've labeled load provider, which receives the GUID to load and the provider that was loaded. And if we take a look at load provider, well, we can see that it does a few simple steps. One is to get the string from the class ID. So it's going to convert the GUID to a string, and then using string formatting, it'll access the registry. So it's going to access the class ID, and then in proc server 32, where the path of my provider is going to be stored. Then we'll actually do the registry access, which is the regget value, and finally, after a bit of processing, we're going to call load library on our provider. After that, we have a bit of COM initialization, which we're not going to go into. But when we go back to the function that's in charge of loading all the different providers, then we can see that there are two more things that take place. One is to copy the loaded provider into the list of loaded providers. And two is increment the number of loaded providers. That's pretty simple. Now this takes place in a loop for each GUID that is enumerated in the registry underneath the AMSI registry key that we saw before. So now we know that registering a provider is broken down into two steps. The first step is registering a COM object in a normal fashion underneath the class's root class ID registry key. And the second part is creating a key with our provider's GUID under local machine, software, Microsoft, AMSI providers. Now once we do that, we can run PowerShell. And PowerShell, and our provider, sorry, was going to receive every single request that PowerShell sends, which means every single command that is entered explicitly or implicitly will arrive at our provider for scanning. So let's take a look at this. So what I have here is a virtual machine. Right now my provider is not registered. I'm going to, that's a bit slow. What I'm going to do is I'm going to check if my provider is installed with a command line. Then I'm going to install my provider, check that it's installed again, and see that it's now going to be installed. And then we're going to see it in action working. Okay. There we go. Some resolution problems. So as you can see, we can see the Windows Defender GUID, which starts with 2.7. And we can see that our GUID was nowhere to be found. Right? So now I'm going to install my provider. And now my provider is installed. And once I run PowerShell, well, what my provider does, it'll simply debug print all the scan requests so we can see them with debug view. So PowerShell is run. And we can see my provider has started printing. And let's clear this. And if we go for example, we'll type ipconfig, we can see ipconfig right here. It's been scanned. Now, if we take a look at what Microsoft calls the AMSI test sample, then when I try to run this, I'm going to do it in 2 steps. I'm going to first load it from base64, right? And now this variable here, AMSI test sample, contains the AMSI test sample, but it hasn't been run yet. And as you can see, this is the command that was entered. And now I'm going to execute the AMSI test sample by calling invoke expression. So let's delete everything here and enter. Now you can see that Windows Defender was able to catch the AMSI test sample. And the reason for that is because we have 2 lines here. The first is the invoke expression, but the second is what expression I was invoking. So I never typed this. This has been called sort of implicitly, but this is the power of AMSI. It allows me to see everything that goes on in PowerShell. So now that wasn't very hard to do, and why is it such a secret? I really don't know. Microsoft has decided to keep this undocumented, and I would kind of like to know why. As for scan dispatching, we know how AMSI loads its providers, but we haven't seen how AMSI dispatches its requests. Can providers fail? What happens if they do? Well, we do know that they return error codes, and the error codes can indicate failure. So what will happen in case of a failure? So back to AMSI DLL, we can take a look at the function scan. Now this function right here will be a very simple function. What we can see here, it'll set the result to be not detected at first, and then if nothing changes, this will be what will be returned. And then we can see that we have a loop here that will create an AMSI provider iterator that will iterate through the list of AMSI providers, and for each provider it's going to call its scan method right here, and whatever the result is, it's going to be stored here in this variable, scan return value. Now, if we take a look towards the end of the loop, we can see a condition, and that condition checks if the return value was SOK. Now, bear in mind, here we're not talking about the result of the scan, whether it was malicious or not. This is, did I successfully scan the buffer that was passed to me or not? So regardless of the result, we're going to either go right, which means the result was okay, stop the loop, don't continue to the next provider, or we're going to go left, which is the result was not a success, so continue to the next provider. Now, a brief summary is that providers are loaded by their GUIDs alphabetically, so I can choose what my GUID starts with, and a lower GUID means that my provider will be loaded first. So all providers will be stored in some list of providers, and whenever a scan request arrives, it will dispatch the scan to all the different providers in that list. If the scan succeeds, we don't continue to the next provider, and if the scan fails, we do continue to the next provider. So we do know how to register a provider. This does require administrator access, but if we register a simple provider that always returns SOK and that the result is result clean, then Defender will never receive the scans, because argue it starts with 1 or 0, because we can choose that. This will essentially disable AMSI completely, and there will be no indication to the user or to Defender. So this is a pretty cool trick, but I wouldn't go about calling it a bypass, because it does require administrative privileges, and you are installing a provider. So in theory, you could also disable AMSI completely. But this is a very nice trick, because there will be no indication to Defender or to the user that something took place. So now we're going to be talking about bypassing AMSI. And we're going to see some very cool bypasses that were previously disclosed in the internet. And we're going to see some new things. But the crucial thing we must understand is that when trying to bypass AMSI, we need to understand what AMSI is there to solve. So according to the blog post by Microsoft that explains what AMSI is good for, the crux of the issue is that scripting engines can run code that was generated at runtime. This is where the new anti-malware scan interface comes in. While the malicious script might go through several passes of deobfuscation, it ultimately needs to supply the scripting engine with plain unobfuscated code. So AMSI is a technology created to help in the battle against script-based malware. AMSI assumes compromise. So if you're running a script, you're already infected. And AMSI says, I'm going to take away the attacker's ability to obfuscate code. So if I have a known malware, a known malicious script, no matter what you do before you run the script, eventually you have to supply the script to the PowerShell engine, which means that I'll be able to scan it without having to understand what kind of procedures and processes and deobfuscations you're running before that. So some of the bypasses that we're going to discuss are not as troubling because they're implementation flaws, and basically it's something that the developers of AMSI maybe overlooked, but these can usually be fixed without much effort. So let's see some examples of these. So Matt Nelson posted a great blog post, and you can check it out in this link right there. But what he figured out is that the anti-malware object is loaded as a COM object, just like the providers themselves, with co-create instance. So when he looked at process monitor, he was able to see, I don't know if you guys can see well, but he was able to see that the anti-malware or AMSI DLL is loaded from the registry under the current user hive, the HKey current user first. And that fails, which you can see the name not found over there. And at this point he figured, okay, well I'm just going to create this, this registry key because I can. I don't need administrative privileges to write to HKCU. And I'm going to put a reference to a DLL that doesn't exist. And at this point, this causes AMSI to fail, and PowerShell continues without loading AMSI and does not scan anything. So this issue was fixed. Then another great post by Satoshi Tanda, also in this blog post. What he found out is that, as we all saw, PowerShell uses AMSI scan string, and AMSI scan string assumes that you're passing to it a null terminated string. So that means that if you put a null terminator inside of your script, AMSI will not scan past that null terminator. And so what he did was he created a little command that contains something benign, a null terminator, and then something malicious, and that thing completely bypassed AMSI. Now this also was supposed to be corrected. I haven't seen the commits on GitHub, but I think it's supposed to be fixed. Another little trick, and I don't know who to attribute this to, but if you copy PowerShell to a different directory, and you can do this without administrator access, then you can simply run it, and it'll try to load AMSI from that directory, AMSI.dll. So if you drop a rogue AMSI DLL in that directory, and you can simply just copy the original AMSI directory and patch it before, so it doesn't really require you to create a DLL of your own. And you put that DLL in that directory, it will be loaded instead of the original one. And this can also effectively disable AMSI. Now, if you do have administrator access, notice that PowerShell lives in a subdirectory of system32, which is Windows PowerShell v1.0. So it'll try to load AMSI DLL from that directory as well. So if you do have administrator access, you can simply drop the patched AMSI DLL in that directory and then run PowerShell, and that'll work, and also disable AMSI. As you can see here, an example that I played with it, and I saw that it's actually able to load AMSI DLL from the PowerShell directory, and the operation is a success, and it does work in mitigating or stopping AMSI from scanning. 1 second. So we talked a lot about PowerShell. I wanted to take a look at VBScript and JavaScript as well. So I took a look at VBScript and JavaScript.dll, and without going into much detail here, we can see that they both contain a class called OLE_script that has an initialize function, which will call the AMSI_initialize API call. And then later on, they both have the check dynamic code safety, which will be called to check code dynamically. And this calls AMSI scan string also. And when looking at the code, I noticed something very, very interesting. I took a look at one of the functions, and I saw that actually a string is being referenced from the registry, and that string is AmsiEnable. So I figured, well, this looks like a bypass waiting to happen. But I figured, well, for sure this happens from the local machine where I won't be able to access it as an administrator, right? No. So as we can see, it explicitly requests this to be accessed from the current user. So I thought, okay, I can write to this and see what happens. And I also took a look at what registry key is being accessed, and we can see it's software, Microsoft, Windows script, settings. Now, Windows script doesn't exist, at least not in my up-to-date version of Windows 10. There's Windows scripts host or scripting host, but there's no Windows script, let alone settings, let alone the value inside AmsiEnable. So essentially, VBScript will try to access this value, but it doesn't exist. So it'll just continue as if this value doesn't exist, and AMSI is enabled. Now, if we take a look at a demo of this, we can see that here I have a VBScript sample that'll load the AMSI test sample into a variable. And we can see here that if I take a look at this registry key, it doesn't exist. If I try to look at this registry key, also doesn't exist. And this script will have another variable that says, should I try to bypass AMSI using this AMSI_enable trick? So first what we're going to do is we're going to disable Windows Defender for demo purposes. And now I'm going to run the script. And as you can see, we have a message box with the AMSI test sample. Now, when we enable the protection, we can double click it, and we can see that this time an error occurs. We have threats found by Windows Defender, and the script contains malicious content and has been blocked by your antivirus software. So what we're going to do now is we're going to leave Windows Defender on and just use this little bypass, should bypass AMSI, and this will create the registry key. Now as you can see, the registry key still doesn't exist, right? And when we double click the script, it'll pop up the message box. And we know that AMSI was bypassed. Okay. If we take a look at the registry, we can see that this value was actually created. Okay. So this is a summary of what we need to do. We just need to create a value AMSI_enable to be 0 in H key current user, software, Microsoft, Windows script, settings, AMSI_enable. Sorry, without the AMSI_enable at the end. So these were all what I like to call implementation issues, things that can be easily patched. As you see, like the previous one was just something that shouldn't be in the code, just remove it. And Microsoft will fix all of these probably. Some of them have been fixed already. But what if we have fundamental issues in AMSI, like issues that are not just implementation flaws, something that is not so easy to fix with a patch. Then we have a more serious problem. Let's take a look at some examples of this. So, do you guys think that it would be possible to bypass AMSI with a command line that would fit into a single tweet? Well, let's recall the AMSI init failed field from the beginning when we took a look at PowerShell's code. Now, what if we can somehow manually set this to true? Then scans will not be dispatched, because as far as PowerShell is concerned, the AMSI initialization process failed. Now, PowerShell is a very, very powerful tool. So without administrative access, Matt Graeber was able to literally tweet an AMSI bypass, and you can check this bypass right here. As you can see, what he does is he references the class AMSIUtils. He accesses the AMSI init failed member, and then he sets it to true. We can see this also in action. And the interesting thing about this bypass is, if we take a look at the date of this tweet, it's from May 24th, 2016, which is nearly 2 years ago, and this bypass still works, at least in my experiments. Even as is, it doesn't even have a signature for it in Windows Defender. So literally, attackers can just use this this command line to bypass AMSI and completely disable it. And the cool thing about it is it doesn't need administrative privileges. So in my opinion, this is the best AMSI bypass to date, the most original and the most sophisticated. So if we copy paste this code here, we can see that we were able to create the sample, try to execute it. Windows Defender says no, the script contains malicious code. So we disable using Matt's one-liner and execute it, and as you can see, AMSI has been disabled. So this is pretty cool. Now, one more bypass is that PowerShell allows you to access native API as much as you want using native API calls. There are literally numerous ways to bypass AMSI. There was actually a publication by 2 researchers from CyberArk describing an AMSI bypass by loading a native DLL from disk. So you drop a DLL to disk and then you load it. But let's try to demonstrate a more simple approach to this. We know that PowerShell calls eventually AMSI scan buffer. And we know that AMSI scan buffer is in charge of passing the scan requests to the providers themselves. So what we're going to try to do is, without administrator access, we're going to try to patch AMSI in memory, the DLL itself, and we're going to replace it with something along the lines of this right here, which is move AL1 return, which means basically return 1. Now, since we expect a scan to return 0, which is success, this is going to be regarded as an error, and it'll allow us to bypass. So, take a look at this. As you can see, we're using the API get procedure address on AMSI DLL to get the address of AMSI scan buffer, and then we're going to call virtual protect to make that memory writable, and then we're going to use memset to write byte by byte the new opcodes that will disable AMSI. So here we have some helper functions that I'll be posting online later, but I'm going to paste them into PowerShell. As you can see, Windows Defender doesn't mind because these are legitimate functions. And then what I'm going to do is I need another helper function, which is get Win32 functions, which will give me access to virtual protect and memset. And this I copied from another repository on GitHub. And when I run this and hit enter, now I have a problem with AMSI. It says that this is malicious because, well, I copied it from somewhere that AMSI was aware of. So what I'm going to do is I'm going to bypass this incredibly sophisticated protection by deleting the T in virtual protect and the corresponding T here. And this is effectively good enough to bypass the signature. And now I'm going to copy the function we saw in the slide before. All right, paste it, and create the test sample. as we've always been doing. Now we can test if we are administrators. And as we can see, we are not administrators. We are not administrators. And when we tried to execute the sample, we have a problem because we haven't disabled it yet. So what we're going to do now is we're going to call the patch function and then run this again, and it works. So we took a look here. We tried to run it. We had a malicious content error. We patched the DLL in memory, and then we executed it again, and it worked. So AMSI, should we keep it? Should we toss it? What should we do with it? Well, the good things about AMSI is it allows more visibility for antiviruses and security products, and so I do think that all security products should implement providers as long as we have AMSI. It's better to see something than to see nothing, and this can help because not every attack will contain an AMSI bypass. And the fact that an app developer can take active part in the user's protection by actually requesting content to be scanned, I think is a good step. It's a good idea. And the fact that you can do it with any content opens the door to many other applications, and I think this is in general a good idea. But the bad thing is, as long as PowerShell can do anything in .NET and access native methods, it'll always be like nearly impossible to beat obfuscation. And the same issues are going to arise when we try to integrate AMSI into other scripting languages, such as Python, for example, because as long as you can control your own memory address space from the scripting language, then you can always mess with this kind of defense mechanism. So to sum up, what we did is we talked about script language malware and obfuscation. We talked about what AMSI was created for. We talked about the internals of AMSI. The design, the API, the structures, the initialization process of the providers, the dispatching of scans. We talked about how one would go about implementing their own provider and registering it. And then we talked about bypassing it. We talked about implementation issues, the COM Server Hijacking by Matt, the null terminator bug by Satoshi, the AmsiEnable bug in VBScript and in JavaScript. And we talked about fundamental issues like the one-liner that Matt showed and the in-memory games bypass by using in-memory hot patching. So at this point, I'd like to thank you all for coming. I hope you enjoyed and you learned something, and I'm here to answer any questions if you have them.
So, may I ask a question?
Yeah, go ahead.
Well, is it AMSI which is run when you open the macro in the document? Is it AMSI that is blocked? Because we have a problem, it's easy to bypass almost all the antiviruses when they use macro. But it's really hard to bypass Windows Defender for me. Mm-hmm. Hard to bypass Windows Defender. Is it AMSI which is blocked here?
Well, it depends. I think that macros use VBScript.dll. So in this case, some functionality will be sent to AMSI, so it could be, but whatever is being blocked in your situation could also be something else.
I don't know, maybe you know some mechanism in the Windows Defender or something which can be run and you can share this information with us.
I'm not aware of anything specifically, but many vendors implement things around the macro because we know that's a sensitive topic. So at Ensilo where I worked, we had something, and I'm sure every other vendor has something there with Windows Defender. So there's probably something to try to block macro content from running malicious stuff. And also AMSI is there probably because it uses VBScript.dll. So
thank you.
Welcome. Any other questions? Okay, thank you.